Hello, everyone. My name is Mr. Anderson, and I am mean to people on the internet. I try to be polite about it, though. I just tend to ask people difficult questions and insist on the answers. You can think of my channel as kind of like a self-defense course for getting into fights on the internet. On my channel, you'll find a lot of stuff to do with debate. I do a lot of post a bunch of my own debates. I do a lot of breakdowns and analysis. And when I'm very, very lucky, I get to do debate reviews with some of the lions of the young Earth creationist and evolution debate world. And I am such a lucky fellow tonight because I do have one such lion here with me, and that is Dr. Dan Stern Cardinal, PhD, biologist, evolutionary biologist, and YouTuber extraordinaire. His YouTube channel is Creation Myths, and he was very kind to join me tonight to talk about an excellent debate that he had recently with somebody from the Discovery Institute named Dr. Corey Luskin, with respect to a little subject called junk DNA. Hey, Dr. Dan, how are you doing?
Hey, I'm great. I'm thrilled to be here and chat about this. That was a very kind introduction. Thank you. I appreciate it. It's Casey Luskin, but yeah.
Did I say Corey? I
Yeah,
misspoke. Casey Luskin, my mistake.
Yeah, I'm thrilled to be here. Thrilled to talk about this with you because as we'll talk about, I've consumed your content in terms of things you can do in debates to accomplish things in those debates, and I may or may not have utilized some of those things in this particular debate. So I'm really excited to be going over this with you.
Oh, I'm excited too. So let's start by just talking about what junk DNA is and the shape of this kind of the larger debate before you got involved and before you got into it with Dr. Luskin himself. So I'm just going to say a couple of things, and I'm going to ask you whether I got it right, and you tell me whether, how off base I am, right? So people often refer to DNA as being like a blueprint or like a code or like a book the size of an encyclopedia. And these are all inexact analogies, but we're going to use a bunch of them anyway, so that lay people can understand what it is you did here, which, by the way, was beautiful. So to understand junk DNA as a concept and why it matters to the creation evolution debate, I'm going to use the analogy of an encyclopedia. Now, the information in your genome is kind of like that. There's a lot of it, and it's kind of used like a reference book rather than being more like a story that you read cover to cover. Is that fair?
Yeah, I actually like that. Yeah, you go in and you pick out the parts you need when you need them rather than just kind of end to end. Yeah, I like that.
Yeah. And we can separate the kinds of information that we find in the genome into sort of two main categories. There are the coding genes, which are, we could think of them as something akin to like the actual articles in the encyclopedia. And then there's the regulatory genes, which are more like, the table of contents and the page numbers and the headings and the index and see also sections, that sort of thing. They kind of tell you where to find the information you're looking for and when to start and stop reading, that sort of thing. Is that fair?
I'm down with this analogy so far. I like this. This is good. Yeah.
Okay. So now, within the context of a creation versus evolution debate, creationists are rather wedded to the idea that God wrote this encyclopedia, and therefore he obviously did a good job, and pretty much all of it is useful in some way or another. And then in contrast, you and the majority of the genetics community are saying that like large chunks, in fact, the vast majority of these articles are gibberish. But the table of contents is still good enough to like allow the reader to find the good articles. And the articles that do make sense are just like so good that this encyclopedia is still being shelved in every school library, and we're printing more copies by the day, right?
Yeah, that's pretty much it. It's that you have the idea that a created or a designed genome should be highly functional. And therefore, if we find that genome that is 80, 90, almost 100%, where every nucleotide in that DNA sequence does a specific job, then that's indicative of creation rather than evolutionary processes. We expect evolutionary processes to be kind of messier and result in things that, yeah, there's parts of it that are important, that are functional, they do really important jobs. We need those parts. There's also parts of it that are kind of broken. They're the result of other processes that are undirected, and they're there. There's no cost to having them there, but they don't do an important job. They just kind of sit there, and maybe they do something or maybe they don't, but whatever they are or are not doing, it's not helping the cell in any like affirmative way, right? And we call
Right.
those regions junk DNA. And I will say that that this is something that's interesting in terms of a creationist argument for two reasons. One is that it's really kind of this weird bank shot because it kind of doesn't matter one way or the other in the grand scheme of things, right? Like,
Mhm.
there's nothing about evolution that precludes a genome that is highly functional. And in fact, that's what we see in a large number of organisms. We see what we call them very compact genomes, where it's really just the genes and the regulatory regions and that's it. And there's very little
Mhm.
junk. And you could also have a designed genome that has a bunch of non-functional stuff in it. And you could explain that in a bunch of ways. Like, we can't know, you'll hear creationists say, like, well, we don't know what God intended. And they'll also say, when you point out that a region is not functional, but it appears to be like a duplicate of another region, they'd be like, oh, well, that's like a backup copy, or that's like something that was put there so that it could become useful in the future. It's like, well, okay, if that works for this one small thing, why doesn't that work for most of the genome? So, like,
Why is there
it's
a
a very
backup copy for the the brown hair gene, but not for the I can blink my eyes gene?
right. It's a right, but it's like an inactivated thing, but it'll become active in the future. It's this kind of basically like there's nothing about a creationist perspective that precludes a genome that is either high or low function. In particular, the intelligent design creationists like Discovery Institute, they really like this idea of a highly functional genome because they think that is kind of consistent with what you would expect out of something that is designed.
Yeah, fair enough. And from their perspective, then the rejoinder, of course, to the no, there's big parts of it that are junk, is that, well, look, just because you don't understand parts of that encyclopedia doesn't mean those parts aren't good,
Mhm.
and that they aren't still helping the kids get good grades. You just don't know what they're for, right?
That's a lot of what it is, and spoiler, that's a lot of what happened in the debate was me being accused of making this argument from ignorance of, well, we don't know, therefore it's junk. But that's not what it is. It's not, we don't know, but it might still be doing something. The whole point is that we can look at it and biochemically evaluate it and see what it's doing or not doing, and then say it can be doing these sets of functions or it cannot be doing these sets of functions.
Yeah. Now, what happened as a result of this debate is something rather special because you were able to force the Discovery Institute to admit something that, I mean, they've always known to be true, but which they very much swept under the rug. Uh, and now you've put it on blast and they're reeling. Tell us a little bit about how much back and forth you've seen from them over the last month and a half or so since the debate.
Yeah, so the backstory here is they released a video back in March that was just like about junk DNA, and it was just like not good. So I did a video responding to it, and what followed was a back and forth. They said my video was bad. I responded to their thing, and this resulted in me and Dr. Luskin having this debate. And in that debate, Dr. Luskin said like directly that we have yet to document function for 50% of the genome. Like the amount that we can say this part of the genome does this specific thing is below 50%. And I was surprised when he said that because the party line for as long as they've been talking about this is that the genome is mostly functional. We have evidence that the genome is mostly functional. They endlessly quote this line from a 2012 paper saying that they were able to, in the paper, the author said, we're able to assign biochemical function to 80% of the genome. And if you're assigning function, you're saying this DNA does this job, right? That's what assigning function means, right? Like, if I assign a grade to a student, I'm saying this student gets this grade. I'm not saying I'm going to figure out your grade in the future. I'm saying you get this
Mhm.
grade, right? That's what that word means. Uh,
Typically.
so, so they just quote this little bit of that paper just endlessly. And they've written, I mean, dozens, if not hundreds, of these articles over, since 2012. And so, acknowledging that at present, the state of our knowledge is we have not documented function for even half the genome, never mind 80%. That was like, I didn't expect him to say that, because yeah, that's true. And I think everyone knows that's true, but that's not the case that they've been making for all these years. So
Yeah, they've been deliberately saying something quite different from that and sort of not acknowledging that fact.
Right. So I, like, right after the debate was like, hey, had this debate, here's the big takeaway right here. And this has resulted in 4 or 5 articles and a podcast from Discovery Institute since the debate. Basically, reflections on the debate. Did Dr. Dan make us change our position? No, he didn't. Like, a whole bunch of things. And the fact of the matter is, you could just go back through their old coverage and see, like, they're not doing this hedging. Oh, well, we don't know yet, but we think we're going to find out based on the trend line. What they said in the past was, you know, they've used the phrase over and over again, the myth of junk DNA and, you know, the death of junk DNA. They've, like, very absolutist kind of claims surrounding this idea, making it very clear to a reader who is not, like, engaged in the field that this concept is not valid anymore. And just going back 1 minute, the second thing I wanted to say that was a little bit interesting about this topic overall is that it's one of the few things that creationists bring up where there is actually genuine disagreement among biologists. Other stuff that other creationist arguments that they bring up in kind of the genetics and evolutionary biology realm, things like created heterozygosity or irreducible complexity or genetic entropy, like, nobody outside of creationist kind of circles takes any of these ideas seriously. But you will find real, legit biologists who will say there is little or no junk DNA in the human genome, and they're wrong about that, and they make bad arguments. And it's, I think, clearly the case that there's quite a lot of junk DNA in the human genome. But that is just one interesting wrinkle to this. It is a kind of realm of creationist arguments where there is a genuine disagreement among real biologists. But that was just a little aside. That was a little aside to the backstory of, since the debate, they have tried to convey that this is actually consistent with the position that they have held for, you know, the last decade plus. Which, if you go back through their work, it's very clearly
it's not. And they can say that it is all they want, but, you know, the just as important is, you know, just as important as to whether or not they have always said it, is the fact that they are saying it now, right? And and that you have this admission and that it's being sort of written into stone at this point, which is just completely beautiful.
Right. They can't walk it back now, because now they've got 6 weeks of saying, not only is this our position currently, but this has been our position forever. So now they can't, next week, they can't start saying the myth of junk DNA. We've found that 80% of the genome. They can't say that again, because now, like, that ship has sailed.
So now, ultimately, it doesn't matter whether they've always been saying it. They will always be saying
now.
It now.
They're stuck. Now Discovery Institute is stuck unless there's, like, significant research advances. And what they like to say, and what Casey said during the debate, and what people say since, is, well, the trajectory of the research is in favor of the idea that there's less junk DNA because we find new functions for things as research progresses. And that's true.
Sure.
But the current number that we're at is like 8 to 10% functional. And in fact, it's actually started to go back in the other direction, right? You had this 2012 paper that they said 80% of the genome is functional. And one of the authors of that paper at the time very famously said, and we expect that number to go to 100%. Since then, many of the authors of that paper have, like, walked that back, and they're now like 50%, we don't really know. And even though the percentages for a long time did increase, you know, it's kind of topping out around 8 or 10%. And I think that number is going to keep going up. But you have to understand, it's not that, like, we look at 1% of the genome and we find an additional 1% functional. It's that we look at, you know, parts of the genome, specific elements that take up 20% of the genome, and we find 1% function. Well, what about that other 19%? That now goes in the junk DNA bucket. It's not that we don't know, it's that we've looked and it's not there. Right. And that's one of the things that I was
really
repeatedly
big difference.
saying. during the debate that like
Yeah.
it's not a we don't know therefore it's junk argument. It's a no, we've looked thoroughly. It's not doing this whole list of things.
Yeah. Well, so let's kind of break it down then, and let's talk a little bit about how you accomplish this feat from a sort of legal and technical perspective. So, just so we're not burying the lead here, I think, and you can tell me what you think. I think the key for you was this disambiguation between what is possible. This is what we were just talking about, between what is possible and what is plausible. And you argued so strongly about what was possible, and they had no good answer, that they had to pivot and maintain that none of your arguments proved such things were not possible, but only that they were not plausible given current understanding, and that therefore they remained possible. And then you had the wherewithal to sort of switch gears and accept that pivot and then turn it on its head, instead of doing this sort of more natural thing, which would be to insist on the argument that, no, darn it, it's not possible, right? You just sort of
Yeah,
took the
just go with it.
admission. It was like jujitsu, right? You took the admission that for the majority of the genome, chalking it up to non-gibberish, that we just don't understand is not plausible, and just take the win,
Yeah, and
right?
so
And
oh,
go
go
ahead.
ahead, finish.
No, after you.
I was going to say, so this is the thing that one of the things I've been hammering since the debate, in addition to the we don't know, a function for a certain threshold. The other thing is that, and I said this during the debate, is, well, there could be function there. And I said, yeah, there could be function there, but okay, now it's your job, people who are saying there's function, to tell me what those functions are going to be, because we can characterize those parts of the genome. And background, a little biology for everybody. So the fraction of the genome that I really focused on, which was 92% of the genome, is what we call unconstrained. And this means, so you have to go all the way back to the concept of natural selection. And natural selection, in the context that I'm talking about it, is this, there's this form of it called purifying selection. And what that means is basically you have a DNA sequence that's really important, and selection keeps it the same. If it changes, that's bad. So the individuals that experience the mutations that change it, they tend to have fewer kids on average, or they die, or whatever, right? So those changes tend to decrease in frequency, and the sequences that stay the same are the ones that kind of persist in that population, right? So that's
Right. It's not the typical kind of natural selection that we think about, where it's like a mutation arises, which is beneficial, and
right.
then it propagates and spreads through the population. Here
Exactly.
we're talking about the reverse, basically, where a mutation pops up and it gives you cancer and you die. And it's
Right. We're
like
saying
that
you're
gene has to keep popping up. It doesn't spread through the population because the people who carry it die.
right. It's basically you're already, if it ain't broke, don't fix it, right? You're already basically
Mhm.
optimal for this sequence. You have to keep it that way if you want to, succeed. So what
Mhm.
we see is selection against changes. And about 8% of the genome exists in that way, where the sequence, the A's, T's, C's, and G's really matter. And we can
Mhm.
document that if they change, there's a cost to that. So those changes are selected against, and that's purifying selection. And we say that that 8% of the genome is constrained. Now, if you want
Those
to
are the
say,
good articles in the encyclopedia. If you screw
like the
with those ones,
really,
then the kids aren't going to read it, and
then you
they'll
got a
throw that
problem.
copy
Yeah,
away.
that's gonna be like George Washington, right? Like that's when the elementary schooler goes to like write their paper, like those are the ones they're gonna go to. So you
Yeah.
need that chunk. Now, if you're
Mhm.
gonna say the genome is 80, 90, 95% functional, you better tell me what the rest of that genome is doing, right? That other 92%. So Casey's saying, okay, you can't say it's not functional. You're saying it's not doing X, Y, or Z because it's missing these particular sequence hallmarks. You can't say it's not functional. You're right. I can't say it's not doing anything important, but whatever it's doing, the sequence doesn't matter. We know that that's the case. So what I asked during the debate a couple of times and have been asking repeatedly since
Yeah.
is, okay, so what is it doing? You tell me, because you're the one making the claim that all this stuff is functional. So you tell me what it's doing. And I
Yeah.
specifically, there was a moment in the debate where I asked Casey, said, give me a function that doesn't require a specific sequence. And he
I
went
remember.
2 or 3 minutes and just did not answer. And I said,
I hopefully we will have time to talk about that very moment, because I have it. I
okay,
have the
cool.
timestamp.
And then,
But
and then
Go ahead.
The thing is, though, the critical thing is he finally did get around to saying, and now I'm going to answer your question. And then he gave me a list of functions that require specific sequences. That's not an answer to the question, dude. That's already accounted for in the 8%. That's not going to work for the 92%. So that was I think that's kind of the thing you're referring to here, where it's like, you don't know. You're right. You tell me, right? That was kind of the switch. And
yeah,
I've asked multiple times, and they have responded to things that I have said and written since the debate while ignoring every instance of me asking that question.
and that is when you know you've got a good question.
What's the answer,
When
fellas?
they refuse to answer, right?
Yeah.
Like, as you go forward, if every time you get a debate where you've got an outstanding question and that other side has got homework and they're not getting back to you, you've got something.
Yeah.
You got something good. So, and and so from a technical perspective, I think the bulk of the heavy lifting, because like the thing that I want to make clear for people is that, like, although you were surprised that you got that admission, it did not come out of nowhere. Like it came, you forced it. Like, I'm not sure how much you realized, like, that the reason he said that was because of you. It was not an unforced error. It was an error. It was a forced error.
I'm happy to take credit for that.
Well, I will lay it out for you, and I will lay out the argument. You can tell me whether you think I'm right at the end.
Yeah, go for it. Because I want to hear your interpretation of this, because I have an idea of why he said that, but I want to hear your interpretation of it, because I don't know if I buy my interpretation.
Well, I mean, I think the bulk of the heavy lifting here in terms of your corralling him and setting this guy up was actually done in your presentation at the start, which is really unusual in a debate. But the presentation was very compelling, and the argument was just so well laid out that it kind of became incumbent on Luskin to deal with it. And then you kept kind of referring back to it and going back over and over again in your response, which was well done. And he it really kind of drove the debate. It drove the agenda. And that was kind of the first thing, I think, that really kind of set it off. And, I was the kind of, well, we'll get into the next bit of it, but let's kind of talk about this. So just to make sure that everybody's on the same page before we dive deep, let's talk about kind of some of the main points. So you say 90% of the genome doesn't do anything that we can think of. And we know that because A, we know what the things are that do things, and these ain't it.
It's not it. Yeah.
B, like, we know what things that do things look like, and these don't look like those things. And C, if they were going to be things that mattered, then they would be subject to purifying selection, which means that they're not going to change over time, which means we'd all have them. We'd all have the same ones. And for 92% of the genome, we don't. It varies.
What we can document for that 92% is that the way we describe it kind of in terms of genetics is we say that it accumulates mutations at the neutral rate, right?
Mm-hmm.
It's just, there's no selection for or against mutations when they occur in these regions. They just kind of accumulate with, there's no it's not accelerated because it's adaptive. It's not slower because it's purifying. It's just, they happen at whatever rate they happen, and that's the rate at which they build up in there.
So basically 90% of the genome doesn't do anything that we can't do without, because some of us are doing without it.
It's that there's basically all of these important functions that we talk about, whether you're a protein coding gene, an RNA gene that makes RNA that does something but not a protein. It's a regulatory sequence, like you mentioned earlier. And you could have kind of second order regulatory sequences where it's this piece of DNA binds to this protein and then that complex does something, right? There's a bunch of different ways different bits of DNA can interact with each other. And the key to all of these things is that in order to do those functions, whether it's bind to a protein or make a protein or whatever, you have to have a specific DNA sequence to do those things. It can't just be random nucleotides. you need specific nucleotides to be able to do these jobs. So if there's nothing saying keep these nucleotides the same, then it's not saying it's not doing any function, but there's this whole long list of functions that we can then say it's not doing any of these things. And
Right,
those are
because
the
it needs to
functions.
say a specific thing.
Right.
Like,
And
it
those are
needs
the
to be,
functions.
the encyclopedia, like that article needs to be written in English for the kid to get the A when he uses it to write his paper. And if it's not in English, then we kind of
Yeah.
pretty good guess that that it doesn't have to be a particular
Or
way, right?
like for example, here's a literature example for people, right? If we find a play and we don't know the author, right? We unearth like a manuscript for a play, we don't know the author. We say this is Shakespeare, right? Okay, we can look at that play because we know what Shakespeare plays look like. Is it in iambic pentameter? No, then it's not a Shakespeare play, right? Like
Mhm.
straight up. Like in the same way, we can look at sequences in our DNA and say, okay, is it sequence constrained? No, then it's not a promoter. It's not an enhancer. It's not a silencer. It's not a protein coding gene. Like we can eliminate all these things, right? That's the idea. So again, you want to tell me it's functional, great, be my guest, but you got to give me something that it's doing that's
Right,
outside of all that other stuff.
right. And then the last bit of your argument was that 90% of the genome can't be doing anything at all kind of in the normal ways and at the normal times. Is that fair?
I think that's a pretty good summary of the whole thing, is that you just look at the combination of the lack of purifying selection and the lack of biochemical activity at a certain level that would be required to do things. That describes most of the genome.
Right. So basically, like the way that all DNA, like here, just kind of, I'm going to try and say it to you, and then you tell me if I'm right. So my understanding is that like the way that all DNA does things that we know about, um, is through this thing called transcription. And if it's not doing that, then either it's a regulatory gene or it isn't doing anything.
Um, so most transcription's not doing an important job either. That's the thing. Most
Right. But if
like
it's not being transcribed, then
oh
like
yeah,
the effects of those genes are not being manifest in the physical world.
right. If it's an untranscribed region, which is a minority of the genome, but if it's a region that's never transcribed, then like there's only a handful of things it could be doing. We know
Right.
what those look like, and we could be like, okay, it's not doing those things.
Right. And by the same token, if it's not transcribed at a level that is sufficient to have this, the amount of stuff, whatever transcription is that produces, then it's still not going to be able to do anything.
You need a certain amount of RNA to actually
Yeah.
affect, you know,
Right.
the other stuff
Otherwise,
in the cell.
otherwise it's like a drop
And
in a bucket.
that point became a whole thing, which resulted
Yeah.
in me like doing a deep dive into some other stuff after the debate, because that was a teeny little moment of the debate, and then that's like what Luskin and another guy, Dr. McClatchy, that's like what they've wanted to talk about since the debate, even though it was like a teeny little thing. Uh, I don't know why they want to do that, but like
Well, you got to
because it
find something, Dan,
doesn't
because
help them.
you don't want to
Doesn't help
just
because
let this stand.
I did the deep dive on that point that they should have done
I know
afterwards,
you did.
and it doesn't
I
help
saw
them.
that.
Like,
So basically, 90% of the genome does things that we don't need that have no apparent effect, and they're doing them in ways that we cannot detect.
that's a pretty fair, or they that we can detect, but it's a very low level. But yeah, I think that's a fair description. Yeah.
Yeah. Okay. So like I was saying before, I think like your intro was quite strong in that it really set the tone for the whole debate and kind of dictated where the battle would be fought, and it was kind of on ground of your choosing, and you prepared it well. Um, and that was excellent. But now let's talk about a moment where I can add some value.
Go for it. Hit me.
Okay.
I'm ready.
So I'm going to share my screen here. Let's try this one. Come on, you. There we go.
There we go.
All righty.
And I think the key quote in that paper is as follows. They said, for polyadenylated RNA, where it is possible to estimate abundance levels, 70% of the documented coverage is below approximately 1 transcript per cell. Is that pretty much one of the key statements that they're making, Dan? Would you agree with that? Or is there anything else that...
So that's kind of one piece of the data. They go on to talk about non-polyadenylated probably being lower, but it's harder to estimate because it's harder to isolate non-polyadenylated RNA. But then later in it, they actually talk about the criteria specifically with RNA. And I wouldn't say there's like one key line necessarily, but there's specifically a figure where they basically say in the text, they say what we would expect for spurious transcription is both low levels of transcription and low sequence conservation, right? They'd say those are the two things we would expect for spurious transcription. And then if you go to figure 3 and then figure 2 in that paper, they show that most of their transcripts meet those criteria. I think that's really the key thing.
Okay, so
let's talk a little bit about, talking over your opponent's head. Now, normally I would say don't do that, because chances are you're probably also talking over the audience's head. But I am inclined to give you a pass here because it is effectively a subtle dig at the guy where you're kind of pointing out that you can talk over his head, but he's not going to be able to talk over yours.
So two things going on here. One, he's obviously trying to pin me down on this like one line. And like, no, we're not going to do that. We're not going to, like, my argument is not this one line. It's a combination of a bunch of things. And the second thing is that second bit about like, there's this specific line where they say this, and then you look at figure 3 and you look at figure 2, and there were, to do it that way was a very conscious decision. And I would love to hear if you thought it was a good decision or not, but this was a conscious decision with two audiences mind. And one audience was the audience, and the other audience was Casey. And the point that I wanted to convey to both of them, in addition to just like, no, this is a more complete argument than what Casey is portraying, the point I want to get across is, don't play this game with me. I know this paper better than you do. Don't play this game with me.
Yeah, I think that came across, right? Where you were like, no, there's, it's this figure and this figure, and you have to look at these things. And, it was pretty clear that like, yeah. And that's why I kind of give you a bit of a pass on that, where I'd say like, normally I would say, try and be more accessible.
Mm-hmm.
But here, I think that's kind of an exception where you can do that. I mean, as long as you get away with it, right?
That was an intentional brushback pitch is what that was.
Yeah, I kind of guessed. So let's see how he responds. Oh, hang on. Let me just...
there's quite a bit to say in response to these arguments. First of all, we have to understand that ENCODE sequenced many different cell types. And so they were looking at lots of different cell types and lots of populations of cells. And so it's very difficult often to catch a particular genetic element in action. Okay, so this is actually one of the things that ENCODE talked about. They only actually studied 147 cell types, but there are thousands of different cell types in the human body. And many genetic elements are only active at certain stages of the cell cycle or certain stages of the life cycle. So you might have a particular, quote unquote, junk DNA element, non-coding element, which
people who watch these videos at 2 times speed are going to lose their minds right now.
You're right. You know what?
At a very rare time in the lifespan of an organism, maybe like, very, only certain, all kinds of important
guy goes on for like
evolution. You want to see some of the things they're doing. Very
4 minutes.
RNAs, then that's going to be
talking to the present at a rate of, they found that some linked RNAs were present at a rate of 0.0006 transcript per cell, indicating, this is a quote, indicating expression only a small subpopulation of the cell sample. And he said, we calculate HOXA to be present at an average of 0.13 transcripts per cell. So the point of all this is that this idea that many parts of our genome are only expressed they're expressed in low copy numbers on average does not mean that these cannot be highly functional in certain cell types and certain stages of the life cycle. It may be very important to keep them in low copy number. And we have evidence for things we know that are functional that are present only in low copy number. So I don't see why this is a good argument that this is non-functional.
Okay, so now we have a problem because he has deployed a word salad to combat
4 minutes.
Your point. Yeah. About low transcription.
Yeah, and for anyone who didn't watch the complete debate or whose eyes may have like glazed over slightly at various points, his point is that the numbers reported for like how much of the RNA you have fractions of the RNA, which implies that it's an average, right? Which means if you survey a bunch of cell types, you could have one that's really high and the rest are very low, and you get a very low average, even though it could be high in certain contexts, right? That's the argument he's making here. And
Yeah, he
I
made the
said that.
analogy. He stole this from Richard Feynman, I'm pretty sure, that like, so the average, US population, number of kids per household is 2.4 children.
Right.
But nobody has 0.4 of a child because children come in lumps. So you only have 2 children or 3 children or 1 child. But you could have 10 couples having no children and then 1 couple having 30 children, and you would still get to 2.4 as an average. And maybe that's what's going on here.
Basically, yeah.
Yeah.
And you said that really fast, and I said that really fast, and he took like 4 minutes to say it.
Yeah, 6 actually. Okay, so let's talk about how to respond to that. So first, I just want to give everybody a little bit of background. What are transcriptions?
Okay, so that's just basically when you take your piece of DNA and an enzyme comes in and makes a piece of RNA based on the sequence of that DNA, that piece of RNA is called a transcript, right? So that's one transcript. And what we're going on here is this paper that we're talking about, they provided data saying that for most RNA molecules in the cell, for that specific sequence of RNA, the amount of that RNA that's present, it's on average, as Casey's describing it, less than 1 of those specific pieces of RNA per cell at any given time. And we're talking out of hundreds of thousands to millions of pieces of RNA that are present at any given time. So if you have a piece of RNA that's present at a frequency of 1 out of 500,000 or 1 out of a million, right? The idea is that's having a very small effect, if any, on the physiology of that cell.
Okay. Let's kind of, because you're just talking to some dumb lawyer here, right? So let's just kind of dumb this down. Let's use our encyclopedia analogy. So the kids at the school, there's an encyclopedia in the library. The kids at the school, the goal is for them to get good grades. Now they go to the library and they're taking notes from the encyclopedia. The encyclopedia is the DNA. And when they take notes to do their homework, that's the RNA. And sometimes they're going to be taking notes on the George Washington article, for example. Now, if we were to go into the school at any given time and check all of the notes from all of the kids in that school, on average, we would find 1 note on George Washington when we check.
Or you'd find 1,000 on George Washington. You'd find a lot of people taking notes on George Washington, but you'd find almost nobody taking notes on, I don't know, what's some really obscure thing, the Oort cloud or something, right? You'd find very few examples of someone taking notes on this other thing that's just irrelevant in, let's say it's an elementary school, right? No one's talking about the Oort cloud in elementary school. This is a thing in astronomy, and I don't even really understand it, but that's right. It's something that's it's such a low level that it's negligible in terms of the ongoing things.
In terms of whether or not that particular article is going to help kids get good grades.
Yeah.
Probably
exactly.
It's not doing much because only 1 kid in the whole school has a single note on the Oort cloud.
Right. That one weird kid who's really into astronomy that reads these books, in their that was me, by the way. I was that weird kid, right? So you look at my notes and I've got stuff in there that's weird stuff, but nobody else is doing that. So if you lost that piece of the encyclopedia, what does that really matter in terms of the knowledge that the kids are gaining, right? That's the idea. Right. It's such a small amount, it's a negligible impact.
Right. Okay. I think that makes sense. Okay. So let's just jump to your response. Actually, you know what? Your response is pretty much right here.
Yeah, I think it's right. Okay. Because it was a lot to cover there. There's a couple things I want to say briefly, and then I want to go back to a bunch of stuff where I think we agree. But first, I feel like what we're doing with the Kellis data is now I think we're extrapolating beyond what we could say, because we're looking at not a few RNAs, we're looking at the majority of transcription functional, or present at extremely low levels. Like Hox, I mean, HOXA is a protein coding gene, so that's going to be considerably different than like a non-coding RNA derived from a retrotransposon, for example, which is a lot of the activity that we're looking at when we're looking at transcription. There's also a big difference in functions where you're acting on a diploid genome, because a diploid genome, I think you right, can if you're actually regulating a pause there. specific gene that has relatively few
Sure.
copies, you can certainly work at relatively low levels to do that. If you're operating against mRNAs, then that's going to be quite different in terms of the number of targets. But I want to kind of agree with you about it. Yeah, there you go.
Okay. So, was that important, what you just said?
So there's one little bit that really mattered there, which was the part where I said he's extrapolating beyond what the data says in the paper. Because he said it could be the case that you've got the situation where one cell type is a lot and the rest are very low. And that would mean it could still be functional, and you can't say that the low levels of transcription are indicative of non-function. And I said, the data don't say that. There's nothing in the paper that says that that's the case. You didn't provide any data. So I'm going to move on. Because if you're not going to provide data to back up your argument, I'm going to point that out, and then I'm going to move on to something else that I want to talk about. Right? That was my approach there.
So did that stuff that you said in there, because I mean, you said a number of things. You said, I didn't.
Yeah, I mean, because I also talked about the Hox gene thing that you mentioned,
you talked about,
because he was talking about
you
things
talked
that are
about averages. You talked about a number of things, and it sounded to me like they might be important things.
It was basically like he rattled off like a whole bunch of stuff. And I was just like, bing, 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 moving on to this other thing that I want to talk about.
Yeah. And
which there's a trade-off inherent to that, right?
Tough,
because
it's tough. Like,
yeah,
I can't necessarily fault you for doing that, because I think, like, if you have an agenda and you want to drive that agenda, then, sort of just like plinking off their points and then moving to your agenda is often the right strategy. But that having been said, if you do run into a word salad like this and you do want to refute it, then you need to understand that even though you followed it, the audience
people didn't. Yeah,
probably didn't, right? So what you need to do, if you do, and again, like I said, you know what, given what you just told me about how you made that deliberate choice, I'm not going to fault you for making that choice, because I think that was a reasonable choice to make. But let's pretend for a moment that you decided to refute that word salad. So what you need to do in that situation is you need to go back and take the points that were wrong and then bring them out and explain what he said,
right,
and then debunk them, right? And the beauty of doing that is that then all the audience is going to remember or understand about his entire word salad are the portions that you debunked.
Right.
Because everything else was blah, 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 too much, too fast, right? And then the little bits that you pull out, make sure people understand, and then refute are the only thing that anybody's going to remember.
Right. And that's what I'll do in a lot of other contexts, right? I'll do, okay, let me steel man you real quick, make sure everyone's on the same page. Now we're going to talk about why it's wrong, right?
Exactly.
And so in this case, right or wrong, it was a deliberate choice to not do that, because that next part that I wanted to get to was like the linchpin of the whole thing, which was the like, let's talk numbers, let's talk percentages that are doing this or that, right? And basically,
and that's a legitimate that's when you said that, I went, okay, you know what, that is a fair thing to do. That I can't fault you for that decision, because
you can fault me for it by all means.
Well, no, I
go for it.
If I wanted to, I still couldn't, because I don't think that I would be correct, right? I think that there is some legitimacy to doing it that way. That is often what I will tell people to do, right? Is just plink off when they give you a whole bunch, just, plink it off quickly. Don't spend a bunch of time in it. Get back to your point. You're driving the bus. You've got an agenda. Right?
That's right. That's the key. Because what we get into here, if I'm going to go point by point through that, now we get into a problem with the BS asymmetry principle, right? Because he rattled all that stuff off in 6 minutes? It would take me twice that long to make it make sense and then explain why it's wrong. So we're never going to get through all of it. And even if I do, now it's on his terms rather than what I want to talk about. And I have, and I'll tell you, I came in there with notes. I came in there with a specific agenda, and it's right at this part where I'm like, okay, I want to go through these numbers with you. And kind of what turned out to be really important was the next thing here when I asked him a very specific question. And
well, you know what? Let's move on then, because the next thing that you do here is something that I really like. So let's take a look.
A bunch of the DNA, and actually, if I may, what I'm going to do is I'm going to change sides during this debate. I'm going to, you know what? I'm going to be on your side. I'm going to try to get the amount of function in the genome as high as possible.
Okay. So, what inspired you to take that approach?
Because here's the thing. I've done this. I have had this conversation before with this was a couple of years ago. I had Dr. Fuzz Rana on. He is now the director of Reasons to Believe. I actually had him on the day before he became the president. I think he was the vice president, and then Hugh Ross retired, and then he became the president. I had him on my channel. It was 2 summers ago. And it was the day before he was to officially start as president. And he's I'll just say, Dr. Rana, super nice guy. And here's a dude who is the president of this. It's an old earth creationist, kind of organization. And he took the time to talk to some rando, and at the time I probably had 4,000 subscribers. And he talked to me for an hour about junk DNA, and we had a really good conversation. One of the things we did was I just want to pick your brain and go through and where do you land on this? What number do you have? And let's look at the parts of the genome. And coming into this, I know you can do that. And I actually have a book on my shelf right there by Larry Moran called What's in Your Genome? And there's a table in there where he does this exercise where he tallies up all the parts. And you do this exercise with the numbers, and you get 8 to 10% functional, 12, maybe 15 if you're absurdly generous. So I said, all right, let's work together, Casey. Let's switch sides and get that number as high as we can. Let's tally up all those parts of the genome, and you're going to tell me what the numbers are, and we're going to see how high we can count here, because there's no way you can get anywhere near even 30%. In an honest way. So I'm saying, let's do it. Let's put your money where your mouth is. You're saying it's, whatever number it is, you pick the number. And this was almost a trick that, it's one of the TV shows I like to watch is, Fool Us with Penn and Teller, where they have magicians come in and do the tricks. And one of the things that's really, that you have to explain is when a magician does a trick where they have the other party pick some of the parameters of that trick, right? So I actually had that in mind for this, which is kind of a silly thing to be thinking out in this context, but it's here's the deck. You pick the card. You can look at the cards. You can pick any card you want. You're going to pick the card, and we're going to do the trick according to the card that you pick, Casey. Yeah. What number do you want to pick? You decide. You can go and say it's 80%, which would be really impressive if we can hit 80%. Or you can make your job really easy and say the number's 15%. We're going to hit 15%, no problem. But either way, no matter what number he picks, I'm going to win, because either it's really low and it's easy to hit that number, and they say, okay, but what about the rest? Or it's really high and there's no way we're going to hit that number.
Yeah. Yeah. So, so what happens now is that you guys go through now for a while, and you do this. And number one, you're driving the conversation. Number two, it's very hard for him to fight you because you're on his side. And then number three, the function just doesn't go up as fast as he wants it to or needs it to, and he runs out of sources.
Run out of stuff. You start tallying these numbers. This is 20% of the genome. This is 8% of the genome. This is 12%, right? You run out all of a sudden you've eaten half the genome and your functional fraction has gone up like 3%. Yeah.
Yeah.
And that's if you want to play this bit, this I think turned out to be like the most important piece here. Because when I ask him for a number, right? This, and we kind of go back and forth on it a little bit, but this turned out to be like almost, I feel like by happenstance, like the key thing that ended up coming back into play later.
Yeah. Yeah. Well, yeah. So let's talk about that. So I'm going to just go for just a touch here. Oops. Right there.
Regulates a different part, other parts of the genome, right? So what I want to ask you is what kind of number do you land on in terms of how much of the human genome is functional versus how much of that is junk? And to be fair, I'm going to tell you my answer to that question because I don't think it's fair for me to ask that question and not provide an answer. So I think we have really strong evidence for 8 to 10% of the genome being functional. And I think if you are really generous, you could stretch that to 20 and maybe you could get over 20%. Maybe you could get 25%. So I would be willing for this conversation to say that you could say 25% of the genome functional, 75% of the genome non-functional. That's where I'm at. 25 helps the cell do its thing. 75% does not. And I want to know what your number is, because what I want to do is for us to work together to get as close to your number as possible. I want to go through the genome and build up as much function as we can and get to your number. So what's your number?
Okay, well, we can certainly talk about that. I appreciate you wanting to help me out here, Dan. I'll take that as a gesture of kindness here. Yeah, I mean, I think I feel a little bit suspicious, but I'm gonna give you the benefit of the doubt here. No, but before we go into that, I do want to say, I just want to repeat that you said earlier that this expression level of below one copy number per cell means that these genetic elements, quote, absolutely not, unquote, those are your words, they absolutely not can have any function. And I believe I showed that that is not the case, that they can't have function at low expression numbers. And we see examples of this, and these are from very credible sources. So I think that argument, the main argument that you're saying shows that the genome is largely not junk, or largely, basically not helping us, largely junk. Again, this gets back to the assumption that I talked about earlier, that if we don't know what it's doing, evolutionists tend to assume that it's probably not doing anything. And this is that when we throw that assumption out the window, that's when we get papers that are actually discovering the function for this. So what exact percentage of the genome do I think is functional?
So I just want to pause here and I want to talk about something that you're doing, which is good. It's a great example of what I call mugging. And it is a great way to be able to interject and add things to a debate when the other person is talking without being disrespectful or interrupting them, because you do it with your face, with your body. Right?
I heard the phrase somewhere. It was actually, I forget the guy's name, but it was a guy who was testifying in front of Congress about something. And the woman next to him who's testifying before him was just lie after lie after lie. And he was sitting there making faces the whole time. And what he said afterwards, he said, "My face has no indoor voice." And I took that to heart. When we're in a situation like this, my face has no indoor voice.
Yeah. Yeah. No, a lot of people say, they suggest that you try and stay like stone-faced when the other person is talking. And to some extent that is true. Like if they say something that's particularly bad for you, don't let that show on your face, right? But if they say something that's asinine or incorrect, or they mischaracterize your position, or they strawman you, or they're just going on forever.
Which is what just happened there. That was an egregious straw man. And I'm like, nope.
Yeah, and that's that's a classic example of my old mentor. He used to do the long shake, right? So somebody'd start saying something and it would just be really bad, and he would just go like this, right? And you do it big because there's a judge and they're far away, so they need to be able to see it. So like a little like wiggle is not going to do it, right? And so he'd start going like this.
You gotta ham it up. Yeah. So so this is something that again, a lot of this is like conscious decisions that I have made over many years of doing this. I started my channel I think it was today. I think today might be I got a notification. It was yesterday or today.
Happy chaniversary.
It might be today, might be my channelversary. But it was 2020, so it was 4 years ago. And so I've done a bunch of these things over the years. And like, this is like a conscious decision, a thing that I've started doing because people, respond to it. And one kind of extreme version of this that I wouldn't do in a situation like this, but like if I'm, for example, in an open mic on, a particular young earth creationist channel, what I will do is I'll pull up OBS and hit the virtual camera. So now what you're going to see on my little box is my screen, and I'll pull up PowerPoint slides and start typing.
Yeah, I've seen you do that. And that's good for like if you're muted.
Right? Yeah, well, yeah, exactly. I'll just sit there and I'll just be like, no, wrong. It'll just be like a few words and just be like, no.
But I think this is like just doing with your face is probably like, in a situation like this, at least is probably better than that. Like, just the, the shaking of your head, just saying like, no, none of that's correct, because like, and it's way better than, because I know that, what you used to do is be like, I can't let him say anything wrong. And so you would interrupt, you would jump in.
Yeah.
Like, no, you can't say that because it's incorrect. And then it would cause them to sort of react, and they, and you'd get into, and the whole thing would devolve. And doing it this way, you're conveying the same information, but like, what's he going to say? It's not like you're interrupting him, right? You're just giving a shake. No, that's not correct. And half the time they'll stop and they'll say, you're shaking your head. Why are you shaking your head? And you'll say, because that's a gross mischaracterization of my position, or, sometimes like he's going on, and you just kind of,
Yeah, see, you're the real lawyer. Saying it that way, that's a gross mischaracterization of my position. So you're the real lawyer here, and I'm in my head, of course, I've got my cousin Vinny and everything that guy just said. Right,
that's bullshit.
Right.
Yeah. But I wanted to pull that out, or so I'm going to jump ahead now to 5230, because this guy does, again,
it takes us forever to actually get an answer, but we do get.
Well, no, you don't get an answer.
I don't get an answer, but I get a line in the sand at least.
You get, well, yeah. So here's what happens.
All right. Well, so let me rather than try to pry for a specific number, then let me just. How about we say conservatively that 50-50, half junk, half function, I think would be a conservative estimate for most ID proponents. That sound fair to you?
I would say it's probably going to be greater than 50%.
Greater than 50%.
But if that helps you out, I'm expecting it to be greater than 50%.
Okay, greater than 50%.
I'll go with that. Yeah, I'll go with that.
Let's say, right.
So that's the, and that's the correct way to do it, right? So if somebody won't give you a specific number, ask him for a general one, right? So, the person will be like, how long, since the last time you saw, Mr. Smith, right? I don't know. Okay. Was it more than a week? Yes. Was it more than 6 months? Yes. Was it more than a year? I'm not sure. Okay. So it was between 6 months and a year then. Yes. Somewhere in there. Would you say it was more than 8 months? It was around 8 months. Okay. Right.
Right.
And you just keep bounding them, right? Like, I just want a range then. Well, I don't know. It could have been 6 months. It could have been 8 months. Okay. So it was between 6 and 8 months, and you're not sure where in that range. Yeah, that's right. Good. Right. We have something, and that's a hell of a lot better than I just don't remember, which is what they would prefer, right?
Right.
They want to leave it as open as possible. You want to nail them down. You're going to have to nail them down by degrees, right?
Yeah. And I will say with this 50%, kind of an arbitrary number here. It was like any number would have worked, but it's the kind of thing where I don't want to say 80% because I already told him what we're going to do, right? And he knows that we can't get to 80%, right? He knows we can't, if we do this exercise, we're never going to get in the ballpark of 80%.
Yeah.
I think he knows we're not going to get to 50, but like we know 80 is never going to happen. And if I say something, I've already conceded. I've said, hey, for this conversation, 25 is fine.
25.
So if I say 30, he's going to be like 30. That's nothing. Like it's going to be like that's not going to get me anything, right? So 50 was kind of an arbitrary choice, but kind of not. And it ended up being really important.
No, it was the right number in the right moment. So that was good. Nothing wrong with that. Let's see. 3. Oh, hang on. Let's go to here.
Down. I'm going to provide some data to that effect in just a minute. But let's start with the stuff we agree with first, because I bet we'll disagree about that. So I'm going to go through just real quick.
So that was just a little subtle one, but I liked it because that's what you do when somebody says a bunch. Because like I jumped forward like a minute, he said a bunch of crap, right? And you said just basically, so I disagree with that. We're not getting into it. Let's focus on what we do agree on, right? Because again, you want to drive your bus. You don't want to get sidetracked in all of the jibber jabber that he said. Like, that's good. And now so you're staying on track.
And there's also a point to doing it this way, because by getting him to build up to a specific number with me, we're saying, okay, we agree, right? And then we get to a point at some point, eventually, right? The goal of this exercise, which gets derailed, but like that's beyond the point. The goal of the exercise would be to get to a point where we no longer agree, but now we've already established, like we've checked a whole bunch of boxes of like what things are doing. So now we're like, okay, if
we've
things
looked in a whole bunch of places and we know that Spot is not under the bed and Spot is not inside the piano.
So instead of starting at 100% and me having to argue him down, we're starting at 0 and arguing up. And then it at some point becomes very difficult to argue further up, right? And that's the ball's then in his court for that job. It's his job to do that instead of mine to get it down.
Yep. No, I like it. I like it. And yeah, I mean, it's also in general. So like, here's a piece of sort of general advice for any of the viewers watching, is that whenever you're doing something like this and you're going after somebody that you know you're going to disagree on, ask them all the questions that they will say yes to and that they will agree to first before you start asking them the ones that you know that they will fight you on, because that way you'll get the ones that they will agree to. If you start with the hard ones, the ones they're not going to agree to, first of all, at the start of the fight, they have the most energy and they will fight you the hardest, right? And secondly, then once they've got their heels set, now you're not even going to get admissions to the things that you would have gotten admissions to otherwise, right? So lay that groundwork first, get the things you can agree on when you can get them, which is going to be at the start before you've shown yourself to be the bastard that you are, right?
I'm nice.
You're very nice.
Very nice.
You were very nice in this conversation.
Very nice.
I have no like criticism in terms of like the niceness. Niceness works and is very effective. And I know people like, I'm fairly confrontational and intense when I do, a cross-examination, right? And like there's a lot of like tension and pressure and like people get nervous when they're talking to me and they say stuff for that reason, right? But that's not the only way to do it. And, you're doing very well with nice. And I know some amazing cross-examiners who would charm the birds out of the trees and get such damaging admission. Like I know this one woman and she's just, she's older now. She was, a looker back in her day. But, smart as a whip, like don't underestimate her at your peril, right? And she would sit down in front of like these, especially like engineers or doctors or older guys, rich guys, and she'd just like look interested, and be asking what, if you thought about it, were very incisive questions, but just with like a, like
Oh,
look of
tell me about
wonder on
this.
her face, right? Like,
Yeah.
just tell me the ways of the Force, master, right?
Uh-huh.
And then it would just become like verbal diarrhea, and these guys would just spew all of their secrets onto this table because this pretty intelligent, like interested,
Yeah.
engaging
Uh-huh.
woman was asking them questions, and then they walk out and their lawyer was like, if he could, he'd have been kicking them under the table. And sometimes they do, which you're not
Shut
allowed to
up.
do. Shut up, shut up, shut up, shut up. Right? And just spew it all over, and they walk out and they think they had a wonderful conversation with this nice young
Yeah,
lady.
and they
right?
sold the farm. Yeah.
They just turfed their $1 million case,
Mhm.
and that's kind of what happened to this guy with you. I mean, you're not
We'll
that
get
good
there.
looking,
We'll
but
get there. It's a journey.
all right, let's just, speaking of journeys, let's jump ahead here. Oops. That's no good. What just happened? Oh,
Let's see.
And we're back. The team is looking down the barrel of a 455
Big
meeting.
one.
450 something.
And I think in reality, most ID
That's jump.
with sequence things like centromeres, which are in the middle of chromosomes, telomeres that are on the ends of chromosomes. You have your scaffolding regions for like protein attachment. You have spacer regions where the sequence of the DNA doesn't matter, but it has to be a certain length, right? It can be 2,000 nucleotides, 1,000 is too few, 5,000 is too many, but as long as it's the right length, the sequence doesn't matter. You add up all that stuff in the genome, it's very well documented, that gets you about 3%. Now that puts us right there. 1, 2, 3, 4, 5, 6, 7, 8. That puts us at 11% functionality with being generous with our rounding. That gets us to 11%. Now we can go one step.
So the interesting thing here is that now I don't love, personally from my perspective, how much you let Luskin kind of ramble on, right? Like I would have cut him off sooner and been like, that's very interesting, sir, but you didn't need like 2 minutes into that 6-minute run.
Yeah.
I'd have been like, I just want a number. Just say a number, right? One word, a number. Say it. Say a number. Right?
5,
like,
20.
Something. Just any number. Say any number. But like you're just rambling, right? That's what I would have done. But you did it a little differently, and you kind of let him go. And now it's paying dividends, though, right? It's working for you. And it's one thing I wanted to bring out is that, like, I appreciate that you have watched a bunch of my videos and you've incorporated, and I can tell you've incorporated lots of the things that I do, but you've made it your own style, right? And it's like, to be good, you don't have to be me, right? You can do it your own way. And the way that you did it was you let him talk, and that then gave you license to lecture.
Now it's my turn. Now I've got stuff that I want to say, and I'm going to take my time to say it. Yeah.
Yeah. And so now, because you've given him that, you haven't shown your impatience, right? You then kind of get this sort of moral license, provided it's the right person, right? This wouldn't work with Darth Dawkins.
Oh, of course. Yeah. No.
Right? Because he would, just cut you off, right? Like,
yeah.
But with the right person, it gives you that moral license, and you needed that moral license because even with this guy, if you had been the way I would be, he wouldn't let you talk.
Mm-hmm.
But you were generous with your time, and so he is. And so now, essentially, what's happened is that you had your opening, and then now you're getting a second or third and fourth, and fifth opening where like we're now basically going through the science and you're taking long stretches of time to lay out science and argument and stuff like that. And he's letting you do it. Right. And that's why.
Right.
So,
and again, this actually, so there's a really funny backstory with this because so one of the things I do on my channel is like, I invite professional creationists on to talk. Like I've had Michael Behe on a couple times, Sal Cordova a bunch of times, Dr. James Carter, not Rob Carter. Rob Carter said no, but James Carter came on one time. Fuzz Rana, Charles Jackson. Like I've had a bunch of like legit professional creationists on, and we have these conversations, and it's always very pleasant conversations. And the only person that ever left feeling I think a little bit sore about it was James Carter. He didn't think that he feels like I kind of ambushed him on the topic a little bit, which is ironic because he picked the topic for that chat. So I don't know how that, but that aside, everyone always, was very happy with it. So a couple of years ago, I actually emailed Casey. I said, hey, I'd love to have you on to talk about this thing. And he basically told me to take a hike. He was like, you're not, I looked at your channel. You're trying to ambush me. I'm not interested. Like, take a hike. And so like when this opportunity came up again, and like we were going back and forth about this video that I did the response to, and he wrote the article and I, whatever. And Steve, kind of, he knows Casey and was like, so like, okay, I'm going to play really super nice because he's expecting like a Professor Dave versus James Tor kind of thing. And I'm going to do the opposite, right? I'm going to be on my absolute best behavior because he like assumed that I was, like a YouTube debate bro, basically. And like, so we're going to do the opposite of that. Right.
Yeah.
And it paid off in this regard. Now I get my time to like talk, numbers that make people go like, oh,
you're playing
numbers.
into your style, right?
Yeah.
Yeah. It was good. All right. Let's see.
Still talking. You can see I'm still talking.
Still talking. He talks a lot.
Yeah, we're just going to count the whole 8% and add it to our already existing 11%, which gets us to 19% functionality, which I think we can agree on that. Casey, I think we can agree on all of those things. We could say that's functional. We're good. Can we agree on that?
You know that thing we do where we go,
Oh, come on,
yeah, I know
YouTube.
I should, but yeah, I know I need to fix my sleep schedule.
I need to fix my
I
sleep
do question
schedule
some of your numbers. So, I mean, I agree it's at least 90% functional. But I mean, for example, I've heard statistics. Do you want me to? I mean, I don't want to cut you off.
We'll get to more. We're getting into more regions, but just like as a first pass, like I think we agree.
even some of your numbers for enhancers, for example. I mean, there have been estimates that there are up to 400,000 enhancers in the human genome, and I just Googled it. Enhancers can be anywhere between 100 to 1,000 base pairs in length, and so let's just split it down the middle and call it, 550. Okay, that's over 200 million base pairs, which is about, it's about 7% of the genome right there that could be enhancers. If you go with, out of our 3 billion base pairs of the haplogenome. So, I think that, or half, the coding strands. So I would say that I don't know if I fully assent to all of your numbers there. Some of them I probably do.
Right,
but some of them I think that we are dealing with cases where this is what we know at the present time, and there's a lot more yet to be discovered, and we're still discovering what these genetic elements are doing.
I'm good with it. Fine. Let's make it. Like I said, I'm here to help you. Let's get this number as high as possible. We're making that 7%. All right. So
but it's not just enhancers. I mean, I think that there's a lot of examples of.
Oh, we'll get there. We'll get there.
We don't know. Anyway,
let's keep going because the rest of the genome, we know what it's made of, and the question is it functional, right? So we've got our retrotransposons are about 45% of the genome. These are RNA-based kind of copy and paste little things that just move around the genome. You get your DNA transposon.
So I like this bit here. The reason I wanted to bring this forward is so you did a good thing. You're like, okay, so we're 19%. You're building consensus. We're at 19%. Do we agree on that? And he quibbles. And it's like, why are you quibbling?
Dude,
do we agree on 19% as a minimum? Yeah, we agree on 19%, but I want more. And, like it would have been so easy to be like, look, let's go through it again. I'll walk you through it again, right? Let me walk you through it again. This is how much you get. And you're like, no, you know what? Which other ones do you want, right? Which other ones of my numbers do you think should be higher? We'll go back. You want 7% instead of what did I have? 5 there? Yeah, we'll change it. So you're at 21 now or whatever, right?
Yeah.
And then so you just like you take his objections. You're like, yeah, no problem. Let's keep the conversation moving forward because again, you have a plan. We know where this is going to go,
and he knows where this is going to go,
right? Yeah. Well, you and I know at least. Yeah.
Well, I think he does too. I think he knows what the.
I think he might have an idea, and then that's why he's like, "I want off this bus," right? And you're like, "No, sit down. Let me just close that door for you. Have a nice seat. Look at that cushy seat right there." And he's like, "No, I want off the bus." I have to pee. I have, it's something, anything to get off this bus. And you're just like, no, we're pulling back onto the interstate. Off we go. Right? There's a toilet in the back. You can use that one. Right? So then you talk for like the next 5 minutes. Which is
No, and
great.
we're just gonna go. I'm just gonna give you numbers. And this is a thing that I do, that I know I do, and some people fall asleep. But like, I like having numbers for things. I like it.
Yeah.
Is it tactically the greatest thing to do? No, because you definitely lose some of your audience when you're just like numbers. But I like having numbers to hang my hat on.
No, I mean, look, numbers are good because they're concrete, right? They're concrete. They're, they're specific. And so like, that's good. Right. Okay. Hang on a second. Now I think here's one of my favorite moments here.
Oh,
come on, you.
YouTube,
Michelin
man.
innovates on the road and far beyond.
Tens of thousands of peer-reviewed papers that have found function for non-coding DNA. At what point would there be enough papers for you to say, okay, look, the trend line of the data shows that my default assumption that this is probably junk, I shouldn't use that default assumption. Even if I think that there's some evidence there for it, this assumption ought to be very dubious. At what point would you be willing to question that assumption?
Okay. Right there. Here's what I want to know. Did you predict that question would be asked of you?
No, I did not predict that question was coming.
Did you have an answer prepared for it?
I don't think the question was like how many papers, I think was the specific question, was how many papers would it take to get you to agree that whatever level of font, wait, that was what he asked? Yeah, I didn't have a specific.
Yeah, he asked it in kind of a funny way, right? But I think what he was saying was, is there anything that would convince you, right? It's the standard,
Right.
Is there anything would convince you? What would it take for you to say, you know what, maybe there's more function here than we expect?
That's it was, and he framed it in terms of number of papers, I think, because just the day before the debate, Discovery Institute on their blog put up a piece where they listed like 800 papers that they said, refute junk DNA or whatever, right? So so that was the framing.
He says that, and then he tries again, like in a minute, or 5 minutes maybe. And he's making different versions of this argument from ignorance, argument from ignorance, argument from ignorance. Did you predict that?
Yes, because I actually said that in my opening. In my opening, there was a whole bit where it's like, here are the arguments I'm not making.
Yeah.
Right. And one of them was, it's not an argument from ignorance. It's not, we don't know, therefore. It's based on specific knowledge that allows us to make this determination. Right. So that one I had in my pocket because I actually had that in the opening, and then he's saying, no, this is what you're doing. And the whole time I'm just like, no, I'm not.
Wait a minute. You had that. You had an argument in your pocket. You scripted something.
Well played, sir. Well played. This is a reference to a recent video,
audience's
folks.
sake, Dr. Dan and I had a very friendly go around about whether or not it was appropriate to have any sort of prepared scripted responses that you can pull out of your back pocket, when the time is right. And Dr. Dan took the position that is not good technique. And I said, nah, sometimes it's okay.
Well, so the specific thing with the scripting is like, I have the same word for word. This is what I'm going to say anytime this topic comes up is the thing, right? That's what, But yeah, I did have this. I anticipated this one was gonna make an appearance, and I addressed it preemptively, and then he does it anyway. I'm like, okay, well, I already,
Yeah, no, and I think that's exactly what you should do. I agree with you. Yeah, it's counter scripting, right? It's, I know this shot is coming. I am going to prepare the response. Just like a boxer will drill like the counterpunch to a particular attack, and so he'll know. I mean, he's still boxing the whole time, right? But, when he comes in and he sees that guy dip his shoulder, like, well, so I know a punch is coming and I know exactly how I'm going to respond, and it's going to be this combination, right?
Right. But then this question right here where you paused it was not that. This question was just like I was like, like that one I didn't do that for this particular one.
That's fair. That's fair.
Yeah.
Well, let's get back. Let's jump ahead then to a different question. This is going to be your question. This is your video. You're the one getting all of this ad
It's so long. I don't. It's. I mean, it's a 2-hour
Functional
video.
endogenous
So,
retrovirus.
but they just want like one theory is that you're saying not to look into this stuff.
All right.
I'm saying for the stuff that we have well characterized and looked into, we can make very confident judgment calls about its ability to do these purported functions. But you've been saying it could do this, it could have this other thing. So let me ask you, what specific
Hold on,
functions? Wait, hang on. No, let me just finish the question. What specific functions could these sequences be doing that do not require sequence specificity?
I'm going to get to that in a minute. I want to.
Yeah, right. He is.
Mm-hmm.
Yeah, that's a good question. And I would have gone about it a little bit like, I think that you get a lot of mileage out of it the way that you do it, right? I would probably have been. So you know what? Here, I'm going to stop talking. I'm going to show you.
No, I want to hear how you would do it differently. I want to. Well, I want to hear your take eventually, though. So hit play, but I want to hear your take eventually.
Yes. Okay. Okay. So he rambles, right? And he's like, I'm going to address that, but let me say something else first.
Yeah.
Right. And then he goes on for about 5 minutes.
Is it that long? Oh my God.
Yes.
It was like 2 or 3. Yeah.
No, it's from 1 hour and 17 minutes to 1 hour and 23 minutes. So that's how long it was, right?
Mistake. As I said in my opening statement, I was predicting that people were going to hear, that the science-stopping effects of the evolutionary view of junk DNA are still in full force. And I feel like I'm hearing that from you, Dan. Now, I think that you're an open-minded guy. I think that if you saw a paper discovering function, you would quickly accept that. But I think that your default assumption here is misguided, and it is taking science potentially in a very dangerous direction, which would repeat the mistakes of the past, where we are concluding that something is not functional when we really don't know that's the case.
So I think, again, that's not what I'm doing, and I can use pseudogenes as an example, and then I'll go back to the question I asked, because it's a very specific question.
Yeah. So if it were me, the first words out of my mouth would have been, thanks for that answer. That was all very interesting, and it doesn't have anything to do with the question I asked you.
Yeah.
The question I asked you was, and then you restate the question, right? You were kind of like, so you remembered the question, which is good.
Right.
But you were like, oh, there's a whole bunch of interesting stuff in there that I want to respond to. No.
No. I know.
Right? No. I have a question. It is a killer. You are trying to dodge it. I don't care what you say. We will get to that if I want to, and I remember. But right now, we are talking about this, right? And you are going to answer this question, and we are going to go around and around and around until you do. Then you can give me, I'm going to ask it again. Then you can give me another 5 minutes if you want. I'll let you talk, and then I'll say, thank you. Again, that was all interesting. And it doesn't answer my question. My question was not a difficult question. My question was a very simple question. Do you remember my question? Sometimes if they go on for a really long time, you ask them that. Yeah. Do you remember what it is that you were supposed to be answering? Or did you just get off on a rant?
There was one of those that a friend is one of his kind of rabbit holes that he goes down is the Alex Jones like conspiracies and the trials specifically, and the all the trials with the I forget the right word, whatever he was accused of, whatever it was. And one of the questions that the lawyer asked him in cross-examination at what point was, what question do you think you are answering? And I need to like write that down and put it somewhere, because that is a really good question for a situation like this, where it's like direct question, ramble.
It's a little too aggressive. It's appropriate for Alex Jones. In this situation where you're playing the good guy.
Yeah, I'm playing good cop, right? I'm playing good cop. It's a little too much for that. Yeah,
I mean,
that's a good one for like Kent, if you want.
Yes, Yes, that is right. So that's what you're different. Like I often say I like to match energies when I'm doing these things, and like I've done crosses, and even on YouTube, I've got some videos where like I'm very nice and very pleasant. People are like, "Wow, like wow, it's the same person as I saw that in that other one." And yeah, well, that's because that person wasn't being a jerk, and so I'm not going to be a jerk. Like I'm gonna be as nice as you. I will hit you as hard as you hit me. It's like we're boxing. I will hit you as hard as you hit me. So, you know, that's kind of how it goes, right? So that would probably be, yeah, that would be a little too hard. I actually met that guy actually, that did the Alex Jones thing.
Yeah,
But
someone in the chat said it was a defamation suit, which I think that was right. Yeah, I think it was.
yeah,
Yeah.
it was a defamation suit. Yeah.
Yeah.
But anyways, where was I?
We were here.
Yeah, so I would just like, I think that in my opinion, the right approach is you stay laser focused. Like when you've got a killer question, right? When you're asking your giant slayer, you stay on it until it's answered. And they might add, like they can say 20 interestingly wrong things and it doesn't matter.
Yeah.
Right? You want the answer to your question and that's it, right? Now that having been said, you parlay this into you still do good. I just that's my opinion, right?
Yeah.
Stay laser focused.
Yeah, because he does eventually he tries to give an answer eventually.
Yeah. And I mean, in a way, what you basically do is you kind of torture him for the next like while on this. Ask him that question and kind of like, well, no, we talked about that. Those are Hawk's genes, and those aren't sequence constrained. Try again, and you make him try again and again and again.
Right, because the thing that he did is he ended up giving a list of several things, all of which require specific sequences to work. So like, well, okay, no, that's not appropriate. What is the actual answer, right? And then, yeah.
So let's, I'm now going too fast. I'm gonna slow down. And let's go to the next sort of segment here.
We are never going to finish this debate.
Yeah, we are. Well, I mean, you know what? I was just going to say I maybe need to speed up here because, I don't want to...
hey, is that Kurt? So, what do you know about
I don't
Tiber
want to keep it
Industria?
up too
You
late.
have to have direct sequence specificity. Coding the pseudogenes is no longer regulate its parent gene. Well, the reality is the degree of sequence specificity is going to determine how tightly it binds. It binds to the mRNA transcript. And so something with less sequence specificity may just have a lesser degree of binding ability, and that may be part of its regulatory role. So, I mean, the exact degree, the fact that it differs from the Aboriginal coding transcript is not a problem at all. The fact that it may even be very different from it. Maybe it's only intended to, bind a part of it and lock that part up.
Yeah,
There are so many possibilities here that I just don't feel like, again, we're establishing clear evidence that this is not functional.
So that last thing you said, I think is really important because you said there's so many possibilities here, but I think that's getting out over your skis a little bit. Because now you're proposing functions that we have not directly documented. And again, the things that you...
So here, you're getting away from your question, right? Because you're starting to talk about, well, you're proposing things that we haven't really got, function for. Like, your question was, I would like a list, right? So make him give you a list because, when he gives you a partial answer, like stop him, clarify that, talk about its significance, and then, set him back on the path. Like, don't let him start to run because if you do, then he's going to start to gallop.
Right.
A particular kind of gallop.
Yes.
A gish gallop.
A gish gallop, if you will.
So when you let him start to run. So when he pops out with one and it's like, here's one, stop him. Right? And be like, okay, so let's just go back to our list. So we have, what was it? Short coding RNA, things, right? And, whatever other thing that you made up. So we've got those two. So you're saying those two. Cool. What else?
What else? Yeah.
Right? And then, he comes up with something. Okay. So the first thing, the second thing, the third thing. Anything else? He comes up with something else. Okay.
Great.
I got 4 now. Anything else, right? And just continue to, and he'll run out. He'll run out faster than you expect, right? He's on the spot too, right? But you know what? You still make a lot of hay out of this, and he goes with something, and then you kind of shoot it down, and you go on like this for like about the next hour, just torturing him with this question.
It can't be that long, but it was a solid chunk of like, here's an answer. No, this can't be an answer. Here's an answer. That can't be an answer.
Look, it's 1:27:37. Okay. And then
we are getting near the end.
It's not an hour. You're right. Yeah. It's another half an hour. It's
because closings, because there was like a Q&A after our little brief closings. So
no, you're right. You're right. So it wasn't an hour. Yeah. It was half an hour. You torture him for the next half an hour.
I don't know if torture's the right word. Like I said, I was nice and
it was very pleasant torture.
It was very pleasant torture.
But yeah, we're not going to go through that in detail because, as you say, like we need to sleep eventually. But it was it was nice. It was good. What the heck is going on here? No,
it like zoomed in for you, I think.
Oh, okay. Well, that's
nice. There you go.
I think we showed that ENCODE's methodology shows that it's doing an average throughout the genome.
All right.
Dan tonight, not saying in years.
All right. So eventually,
on the other hand, function.
This is his closing now, right?
The conversation that any particular genetic element that he cited cannot have evidence of function. So, but instead, I've seen that the literature is replete with function, and the trend line of the research shows that we should anticipate more and more function is going to be found. And I think that these percentages of functional elements in the genome are going to go up, 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 and we're just getting started. I mean, it could be another 100 years before we cross that 50% threshold, but I predict we're going to get there and we're going to go above that.
All right, Dr. Dan, go ahead and do a closer. Then I'll do a quick super chat and then we'll wrap it up.
I just first thank you just at the very end there. I don't know if you meant to do that, but thank you for acknowledging that right now we've not crossed the 50% threshold. I appreciate that.
Not from what we know, not from what
and then he starts backpedaling.
The not from what we know was like, I appreciate that you just dug yourself into a hole, and then he goes, yeah, I'm just going to take a few more shovelfuls before I try to climb out like that.
Yeah. Well, he's desperately scrabbling at the edge, and I don't know if he knows which direction is up at this point.
Before you show the next thing, I will say what I did here was specifically because of a video that you made about a specific technique. So I will say this specific thing was like straight out of your playbook. So thank you. And for everyone watching, like, this would not have gone the way it did if not for Mr. Anderson doing his debate tactic videos, because there was a very conscious choice that I made right here that has since this moment paid dividends, I think. So if you want to say something or you can hit play, whatever, but I want to make that clear.
I'll hit play and you stop me. I'm not going to steal your thunder. You stop me when you see the moment where you make the decision.
Okay.
And then you tell us the moment.
Yeah. What we know.
Okay.
Yeah.
Great. And that's far. I do want to say, no, when I want to start a debate, I just want to say that thank you for saying that, because that is at odds with what comes out of the anti-junk DNA community.
Well, no, there's evidence for function. No, let me say this. There's evidence for function. I think that ENCODE provides evidence for function, and our default assumption should be that it probably is functional. But we haven't specifically identified the function for the vast majority of the genetic element. I said that in my opening statement. You know, this is nothing new. Everybody agrees with this. But what we found is a far cry from where we were 10 or 15 years ago. We have made huge strides towards seeing that the genome is mass functional. I think ENCODE provides good evidence of that.
I liked how Dr. Rana answered that question. Rana answered that question when you asked him. 51 to somewhere between 51 and 100%. Take your pick.
Right. Yeah. No, I do think that is at odds with much of the community, but we'll move on. I'll just kind of briefly summarize kind of from my perspective here. So what I've kind of tried to do, cut it off right there.
Yeah.
So this is a thing that you highlighted at one point. We're talking to Kent with your dog with the canine transmissible venereal tumor and a change of kinds thing. Like when you get the admission and then you move on to the next thing because you got it. Like, don't give him a moment. Don't give him a chance to fix it in the moment, right? Because he could say, no, I misspoke. I didn't actually mean that. Now you lost it again, right? But if you move on, now it's in the record. Now they've got to go back later and clean up the mess, which is what they've been doing.
Way harder. Yeah.
And that's way harder, right?
To do it later.
So this decision right here to not belabor that point and just that's fine. I'm just going to do my closing now, moving on. Like, that was a very conscious decision to like get that point in the record. He said it. He didn't walk it back. We're moving on.
Yeah, that was great. I loved it. And you're right. He was in there. He was like, I'm in a hole. What do I do? I'll dig my way out. No, dig up, stupid.
So thank you for your educational stuff with that, because that like since the debate, this has been like there's literally. So I made a video called "I Made Discovery Institute Change Their Position," and then they had a blog post called "Did Dr. Dan Make Us Change Our Position?" So now I just want to point out for everyone what's been going on for the better part of 6-7 weeks now. You've got the premier intelligent design think tank, funded by right-wing billionaires to the tune of 7, if not 8 figures every year, is engaged in a 2-month, if you go back to March, 3-month, March, April, May, June, 4-month, April, May, June, 3-month fight with a random YouTuber with 4-digit sub numbers. Is that an efficient use of their time for their, I'll call it a ministry? Probably not, but I'll take it. Because every moment they spend fighting with me, every blog post they spend fighting with me, everything they have to do where they're retconning this debate, that's time and effort they're not spending on something else, right? There's an opportunity cost there.
Well, here's the thing, Dan, and I want to gently disagree with you here because, I mean, I appreciate that you see yourself as the underdog, and in many ways you are. But the problem for Discovery Institute is that, look, they've got all the money in the world, or compared to you, they've got all the money in the world, but they can't use it to hire any evolutionary biologists. And so it's like if you're in like there's a war, and one side has all this money, but it can't buy bullets or guns, right? Like nobody will sell them to them. And then the other guy just happens to have a whole bunch lying around his house. Because he is an evolutionary biologist and he doesn't have to hire anybody. And, so like in terms of, the scientific like knowledge and acumen that you bring to the table, like they're not at a massive advantage compared to you. They're, having to fight uphill. I mean, Casey Luskin, he's got a PhD and a law degree, although I mean, I think he's made it clear that not all lawyers are created equal, but it's a geology degree, and he's debating biology with a biologist, and you're beating them, and that's the reason they have to keep coming back and fight with you, even though you don't have a massive, you're not famous, right? But you're the like ideal person with the ideal training who's making the ideal points at the ideal time. And so they're forced to react to you. And that's kind of the thing. Like, you're like, I was surprised that this guy said this. Like, I'm not surprised that this popped out because like, what else was he supposed to do? Like, he's got like, he spent the entire debate, like running from this whole like, no, there is no there like it is not possible for it to be more than 25%,
whatever. Yeah.
And he's like no, it's possible, we just have not there yet, it's possible, we're just not there yet. And I say torture, you didn't torture the guy, but like you're beating him over the head with this idea for like that half an hour that I skipped, where you're like, no, it's not even possible. No, yes, it's possible. We're just not there yet. Why is it surprising to you that that's exactly what he says in his closing? You conditioned him to say it.
Fair.
So he said it.
Right? You know what? I'll take more credit then. Sure. Yeah. Fair. And that's very generous of you, I think, to frame it that way. Yeah, because I didn't set it up that way, right? That was from my perspective in the moment, that just kind of popped out at the end of his closing. I was like, well, this is a lovely gift. We'll just point that out. And then move on.
It was more deliberate than you give yourself credit for. Like, you did that. That was as a result of 2 hours.
The specific number
hammering.
the specific number from earlier turned out to be really important, right? Because say I had picked 80% at the beginning, right? And said, oh, 80%. And he was like, well, I think it'll be more than that, but whatever, right? Now, if at the end, if he says, we're not to 80% yet, but we're close, then that could mean 75%, right? That could mean 70. That's still a lot, right?
Yeah.
But
50.
If we're below, come on, what have we been doing? If you're going to acknowledge we're below 50, right? What are
we're
we?
going to say
What
most
really
of the genome is functional, but we're also less than 50%. That's
right.
not most,
right?
That's not
right. And that
most.
was kind of right. I said like the 50% threshold. It wasn't entirely arbitrary, but it also wasn't like I didn't like pick that ahead of time, right? So that's
some the decision you made in the moment, and good.
Sometimes you got to be good. Sometimes you got to be lucky, right? And that one worked out.
Sometimes you got to be good to be lucky. So,
like I said, I appreciate compliments from you on that because I will take it. I appreciate it.
Everybody should listen to me more. That's what we're gonna.
That's what we've learned. What have we learned here tonight, folks? Listen to Mr. Anderson
and be like Dr. Dan.
Yes.
There we go, everyone. So I think that is probably a great place to end the stream with the, inducting Dr. Dan into the Mutual Admiration Society. And you know what, Dr. Dan, please feel free to post this on your channel, and we'll keep keep the pressure on Discovery Institute, and just reinforce the fact that they know darn well that they're under 50%, and look, even if we double the amount of DNA that we identify jobs for, even if we triple it, you're at 30.
Yeah, you're about 30. Yeah. That's not most. Like, that's not all.
It's not even close. Yeah. So we all know that you're not even close.
And that is now their official stated position, right? They're kind of their line now is the number right now is somewhere south of 50, but we have reason to believe it'll get to 80 or 90 or whatever, right? That's where that's what they're saying.
That reason is not very good, but I mean, it's based on faith, and I understand that. That's fine, right? But the fact of the matter is that as of now, as of everything we know, everything we can think of, you're not at 50, right? And the rest of the genome, the stuff that you're going to have to think of, has to be stuff that doesn't do anything. We can't. It has to be stuff that we don't need, that doesn't do anything as far as we can tell, in any kind of way that we can perceive.
Or at a very low level, right? Some of it is low level activity, but
maybe we can't perceive it yet.
That was like a whole spin-off series to this whole thing, was me actually going to that other paper where the one paper got their data from, and it turns out it wasn't actually averages, and they reported each. It was a whole thing.
Oh yeah, that was
anyone who wants like the deep dive on this, I literally have a playlist on my channel of everything like in this saga of Discovery Institute and junk DNA, including the whole debate, lead up to the debate.
It's lovely, you guys. It's popcorn, right? Because you're just watching this disingenuous argument unravel before your eyes, right?
I'm enjoying it every time it pops up. Like, it's just great. They're just going to keep hitting this button, and then I get to hit it back. And
as long as you can digest the science, and hopefully this video will have kind of helped sort of dumb it down and just kind of distill it to the juicy part that you can just sort of savor the Schadenfreude.
Yeah. And one of my goals here, it's not just I'm not doing this. I'll say I'm not doing this just for fun. It is fun, but I'm doing it because I want other people to have ammunition, right? I want everybody who watches this or watches my other videos on this topic, goes through the debate and the back and forth that I've had with Discovery Institute. You now have, a new argument, right? We collectively have a new anti-creationist argument in our arsenal, right? Every time this comes up, Discovery Institute doesn't agree with that number. They always cite this 80% number. Discovery Institute doesn't agree with that. We haven't found 80% function. They said it's less than 50. They said they've always said that. Why are you saying it, other creationist? Even Discovery Institute disagrees with you, right? We now have this in our pocket to pull out as necessary, which use it, everybody. You see stuff about junk DNA in the wild. Now we have a response ready to go from creationists.
Rock on. All right, you guys, that is it for us. Thank you once again to Dr. Dan of Creation Myths. Everybody go subscribe to Creation Myths if you haven't done so already. And
if you're here and you haven't subscribed to Mr. Anderson, what are you doing? Subscribe to him and share him around, because like more people should see his stuff. It's great.
Thank you very much. And please hit that like button before you go. We'll talk to you later, guys.